Fraud model. 99% accuracy.
Catches 0 frauds. 0 out of every single one.
Both of those numbers are true at the same time. That's the trap this episode pulls you out of. Episode 20. Handling imbalanced data. SMOTE, class weights, and why accuracy can flat out lie to you. Here's the dataset. 990 legit transactions. 10 fraud transactions.
Now watch this. Predict, not fraud, for every single row. You just scored 99% accuracy.
And caught exactly 0 frauds. The model did nothing. The metric lied anyway. Look at the confusion matrix behind that 99%. 990 true negatives. 0 true positives.
Recall on the fraud class, 0%.
Accuracy rewards the majority class and ignores the minority entirely.
On imbalanced data, accuracy is close to meaningless on its own.
Let's watch this dataset get fixed, live. 10 fraud points, 990 legit points, badly tilted. SMOTE picks a fraud point and its nearest fraud neighbor. Then it draws a brand new synthetic point somewhere between them. Repeat that hundreds of times, and the minority class grows to match.
No copy-pasting the same 10 rows. Every point is new.
That's balance built from the data you already have. SMOTE stands for Synthetic Minority Oversampling Technique. For each minority point, it finds its k nearest minority neighbors.
It picks a random point along the line to one of them.
That new point becomes a synthetic training example. It only touches the minority class. The majority class stays untouched. There's a simpler fix. Class_weight equals balanced. No new rows are created at all.
The model just pays more attention to mistakes on the rare class. One parameter, no extra library, no resampling step. Most SMOTE classifiers support it out of the box. In code, both fixes are a few lines each. SMOTE goes inside a pipeline right before the model. Class_weight equals balanced goes straight into the model itself. Same dataset, same base model, 2 different fixes. If this is clicking subscribe, feature selection is next. Same logistic regression, same fraud dataset, 3 different runs. Baseline, no fix at all, 0% recall on fraud. With SMOTE, recall jumps to 85%. With class_weight balanced, recall lands at 80%.
Same model. The only thing that changed was how it saw the classes. A few mistakes come up constantly here. Applying SMOTE before the train test split, that leaks synthetic copies into test. Judging the fix by accuracy again, check recall and precision instead. Oversampling the test set, you never touch the test set at all. Reaching for SMOTE by default on every imbalance, even tiny ones. Every one of these turns a fix into a brand new leak. So which technique, when small to moderate imbalance, plenty of data, SMOTE works well. Need something fast with 0 extra library, class_weight balanced. Huge majority class, memory or speed a concern, undersampling the majority. Already a good model, wrong decision threshold, try threshold tuning first. Whatever you choose, fit it only on train inside a pipeline. Quick recap before we go. The problem: accuracy hides a model that ignores the rare class. SMOTE, synthetic minority points generated between real neighbors. Class_weight equals balanced. Same idea, 0 resampling. Judge the fix with recall and precision, never accuracy alone. And always split before you resample. Where we are in the series, we can evaluate a model, prepare its data, and now handle imbalance correctly. Episode 21, Feature Selection. Fewer features equal or better model and how to prove it. Episode 21, Feature Selection Explained. More features isn't always a better model. Sometimes it's a worse one. Correlation filtering, recursive feature elimination, multicollinearity. Fewer columns, same or better score. Subscribe so you don't miss it. Your challenge task for this episode: build a fraud-style dataset, 990 legit, 10 fraud. Train a baseline classifier. Check recall, not just accuracy. Fix it with SMOTE inside a pipeline. Fix it again with class_weight equals balanced.
Compare recall and precision for both against the baseline.
Bonus. Try random undersampler instead. Which one wins here? Solution is in the repo. Think before you look. A model. 99% accuracy. 0 frauds caught.
The model wasn't broken.
Accuracy was the wrong question. Episode 21, Feature Selection, drops next. Subscribe. Comment below, has high accuracy ever fooled you on a real dataset?